Robots have learnt to see. They have learnt to hear. And artificial intelligence has given them the ability to understand increasingly complex instructions. Now, engineers are trying to solve another problem: how to give machines a sense of touch. In laboratories around the world, researchers are developing a new generation of electronic skin, thin, flexible sensing surfaces designed to detect physical contact, pressure, and other changes in their surroundings. And this could prove far more important than it might first appear. Because if robots are eventually to move beyond controlled industrial environments and work directly alongside people, artificial intelligence alone will not be enough. They will need to understand the physical world. This is StartWBS Technology. Today we look at how close robotics is coming to creating an artificial sense of touch, and why skin, rather than a face or a voice, could become one of the defining technologies of the next generation of robots. Human touch seems simple largely because we rarely have to think about it. Take an ordinary cup. The moment your fingers make contact with its surface, your nervous system is already receiving information. Without consciously thinking about it, you adjust the force of your grip. If the cup begins to slip, your fingers respond. No deliberate calculation is required. For a robot, things are very different. A camera can tell a machine where the cup is. A computer vision system can recognize its shape. Artificial intelligence can understand the instruction: pick up the cup from the table. But then comes the physics. How tightly should it grip? What happens if the surface is wet? How does it detect that the object is beginning to slip? And how does it respond quickly enough to prevent it from falling? That is the problem electronic skin is designed to help solve. The term e-skin, or electronic skin, actually describes an entire class of technologies. These are flexible sensing systems that can be placed on robotic fingers, hands, and other surfaces. Depending on their design, they can detect different aspects of physical interaction, including pressure, deformation, temperature, and the location of contact. But detecting the signal is only the beginning of the engineering challenge. A robot cannot simply register that contact has occurred. It has to determine what that contact means, and then change its behavior accordingly. This is where electronic skin begins to meet artificial intelligence. And it is part of a much larger transformation taking place across the technology industry. Over the past few years, the world has watched artificial intelligence develop at extraordinary speed inside computers: chatbots, assistants, AI agents. Systems capable of analyzing documents, responding to customers, writing computer code, and carrying out digital tasks. But the next stage is more difficult. Intelligence is moving from the digital world into the physical one. A world where glass can break, objects can fall, and people can be hurt. So the question is no longer simply, how intelligent can a robot become? It is also, how safely can it use that intelligence in the real world? Electronic skin therefore matters far beyond humanoid robots. Similar technologies are being explored for industrial robotics, prosthetics, and medical systems where precise physical interaction is essential. But when we say a robot can feel, we do not mean it has acquired a human sense of touch. Electronic sensors measure physical signals. Human skin is part of a complex biological system connected to our nerves, spinal cord, and brain. The difference remains enormous. There are also major engineering challenges. Electronic skin must withstand repeated contact, stretching, bending, and damage while remaining accurate and affordable to manufacture. And if thousands of sensors cover a robot, all that information must be processed almost instantaneously. Perhaps this is the most interesting part of the story. When a new humanoid robot appears, attention usually goes to its face, its voice, and the way it moves. But the technologies that may bring robots into everyday life could be far less dramatic. One may simply be a thin layer of sensing material covering a robotic hand. Because a robot working alongside us needs more than an understanding of what is in front of it. It needs to understand what happens at the moment of contact. Perhaps the next chapter in robotics will not be defined by how much machines look like us, but by how successfully they interact with the world we share. This is StartWBS Technology.